Motivation and introduction from algebra to calculus. For example, I have limit x approaches infinity, 1 over x approaches 0. How we understand this one? Let us see in the graphing calculator. So we type the function in the graphing calculator 1 over x. Now you can go to Zoom 6 for the standard window. So now you can look at the graph that this goes all the way right side, approaches 0, which is considered as a horizontal asymptote in college algebra. So we have the same concept coming in limit of functions. All right, so I'm going to the next one. So the next one is when you take the derivative of 1 over x, that goes to negative 1 over x squared. And the third one is also from college algebra, which is when x approaches infinity, we have seen this type of quantity, 1 plus a over x to the x over a, that comes from the exponential function that you have learned in college algebra. That when this x is very large without bound, then this whole quantity approaches e to the 1. So now we'll be taking few examples from calculus and then see how we apply this concept. So my first question is coming. So this is my first question. And in this section, we'll be applying L'Hopital rule. When I see x approaches infinity, so this is very large, but this one, as you have seen, 3 over x or 1 over x, that approaches 0. So e to the 0 is 1. And then this one is infinity minus infinity is undefined, but not in the form of L'Hopital rule. So L'Hopital rule should have either 0 over 0 form or infinity over infinity form. So we need to somehow do some algebraic work on this and convert this one to the right form. Let us see how we do it. So when we factor out x, we get e to the 3 over x minus 1. Now see what happens when you replace x by infinity. So this one is very large, infinity, and that one is going to 0. So 0 times infinity is still undefined form, not in the form of L'Hopital rule. So what we do, we need to do something on x in here. So this is a straightforward idea like x over 1, again reciprocate, write 1 over x and put it in the denominator. So this is equivalent form. Now what happens? When x approaches infinity, this one goes to 0 and the numerator also goes to 0. This is the perfect shape now, 0 over 0. We are ready to apply L'Hopital rule. So we need to take derivative now in the numerator and denominator independently and then see what happens. Now you can easily cancel x square here. Then negative sign gone. When x approaches infinity, e to the 3 over x goes to 1. And then my final answer is just 3. So we'll see in our graphing calculator whether it is the correct answer. Now I have my function in the graphing calculator, x e to the 3 over x minus x. Now I want to take some window, very large value for x, because we want to check the limit at infinity. So then let's graph it and then see what happens. So it goes like this. Let us trace at some big number, say 99. Yeah, you see that it's very close to 3. So that's why this limiting value is 3 for this one. We'll take another example. So now I'm taking second example, which is limit x approaches infinity, 1 plus 3 over x to the x over 7. Now for this problem, if I consider the algebraic process, then I have 1 plus 3 over x. I need there x over 3, but I have instead 1 over 7. So how do I balance this? We can just write here 3 and then 7. Now the portion on the left side is just e. So then this should give me e to the 3 over 7. This is algebraically we can understand. But let us do this using L'Hopital rule. So what we do, we first write y is equals limit x approaches infinity 1 plus 3 over x to the x over 7. So this basic shape is like when you say x approaches infinity, somehow it is going like 1 plus to the infinity type. So this one is little more than 1, and then when you take your exponent very, very large, so it goes somewhere, we don't know what it is. But then using calculus, we will figure out. But from algebra already we know that it has some bound here, that it will go up to e to the 3 over 7. So that's why I'm taking y equals. Now take the natural log on both sides. So natural log of y will be, keep your limit, is okay. Then you have x over 7, natural log of 3 over x. Now, since we are ready to apply L'Hopital rule, so the term I have here, x over 7, I should put it in the denominator when I reciprocate it one more time. So then it goes like limit x to infinity, natural log 1 plus 3 over x, and then in the denominator you can put 7 over x. This is the perfect shape now. When you see x approaches infinity, this term goes to 0. Natural log of 1 is 0. And then 7 over x also approaches 0. So this is the perfect form for L'Hopital rule. So what we do now? Put limit, keep it here, take the derivative of. So we know natural log of x is 1 over whatever we see, 1 plus 3 over x times. Now I need to take derivative of inside with the chain rule, and you have seen already from the motivation that 1 plus 3 over x, simply derivative gives me negative 3 over x squared. And the denominator 7 over x gives me negative 7 over x squared. Now you cancel x squared, you cancel the negative sign, and then when x approaches infinity, this term goes to 1. So remaining is just 3 over 7. So since this one is from natural log of y is 3 over 7, you have very good knowledge from pre-calculus or college algebra that when you find y, then this one simply will be e to the 3 over 7, and you can see the exact answer, exact matching we have. And we are done. Thank you.